Hello, ladies and gentlemen. Good morning, good afternoon, or good evening. This is our fourth video for our new chapter, What Have I Become? Who are you? Who are you? Well, as this chapter suggests, we're thinking about ourselves. Problem number one is us thinking about what makes us healthy or sick inside. So starting to think about what's going on inside our bodies. Number two is, how do humans impact climate change? We've looked at that already, and we will continue to do that. Number three, it says, how do toxins and pollutants affect our body? So how do things from our environment get into our bodies, and what effect do they have? So it's not just food and medicine that keeps us healthy or sick. There might also be things from our environment, like toxins and pollutants, that could affect us. We're going to continue to think about this question. And then we're going to continue to look at the cells and how they are engaging in chemistry, how they're changing chemical bonds and digesting and breaking things down, using things for energy. We'll continue to look at what they're doing with those molecules to build their own bodies and to keep our body alive. All right, so follow me along. Let's pick up where we last left off. So video number 3, or our last video, we looked at the anatomy of the atom. So we started looking at the atom, and we started to look at what makes the atom, what things combine to make a single atom. So we're going to pick that up, and let's look at a video for a review. So in the last video, we started identifying parts of the atom structure. Officially, you wrote down the definition for electrons, and you wrote down the definition for a nucleus. But the nucleus is a complex structure. But for our class, just remember that the nucleus is the center of an atom. And just remember that the nucleus, even though it is made up of neutrons and protons, right now, I'm just asking you to remember that the nucleus is positively charged, and on the outside of the atom are negatively charged electrons. And different atoms have different numbers of electrons, and they have different strengths of positive charge. So the more positive protons in the nucleus, the stronger the positive charge is. So carbon has a stronger positive charge than helium, because it only has 2. And you can see carbon has 6 total electrons, and helium only has 2. So different elements, like helium, the helium element, its atoms only have 2 electrons. But then the carbon element has 6 electrons. Protons and number of electrons all help the identity of each element, from carbon to helium. As we go further along in the chapter, we're going to learn more and more about how atoms combine to form these larger structures we call molecules, and a new word we'll learn soon called polymer. Let's check out this TED Talk video and see how they demonstrate atoms and their charges, positive and negative, and what role that plays in forming these molecules. As you can see, let's rewind it a little, but it jumps right in. It shows an atom here and another atom. So there's 2 hydrogens. They're drawn together, and these positive and negative charges bring them close. This is hydrogen and oxygen, sodium and chloride. Different charges attract or repel. In fact, this sodium and chloride, the chloride liked the electron from the sodium so much it took one. When an atom pulls and steals electrons from another, it forms this thing called an ionic bond. We'll study this a little later. You see, chlorine stole an electron, and sodium chloride is table salt, which we eat all the time. You can see him stealing it. So next time you think about table salt, just imagine your table salt just being tons of positively charged and negatively charged sodium chlorides all clustering together, forming these huge structures. So it takes trillions of sodiums and chlorides grouped up to make one little granule of salt. Pretty impressive. Sodium, or table salt, sodium and chloride, because one atom stole electrons from another, it's called an ionic bond. Chemistry class talks about this a lot. Our bodies, however, are made up of a different type of bond where electrons are shared evenly. This is an example. 2 hydrogens. Both hydrogens share the electrons. They're drawn together. This would be hydrogen gas. And it's called a covalent bond. Our bodies, our DNA, every molecule in our body, our cells, are generally made up of covalent bonds. So we have different atoms combining, and you can have super complex molecules like this huge structure, CHNO, or you can have smaller ones like H2O. But they all interact together based on their charges. So based on the positive charge nucleus and the negative charge electrons decides if all of these atoms bond together and form larger structures. What we're going to do in the rest of this video is start thinking about how these molecules take shape and start thinking about how these positive and negative charges bring these atoms together. But just remember, the bonding that we will be studying a lot of for our bodies are the covalent bonding. The bonding you see between large structures like this, all sharing electrons. All right, so let's start thinking about positive and negative charges. Let's start thinking about how the atoms themselves and their charges combine themselves, how it starts to forming the molecules. So what we're going to do is this activity, so we can think about positive charges and negative charges, and think about how they're attracted to one another and how they might be able to form those molecules. So in your notebook, write slide 26. Again, we're on slide 26. You hopefully can see on the screen you're having. So 26. In your notebook, write slide 26. And then we're going to do 5 questions. We're going to do 5 things on slide 26. So go ahead and number 1, 2, 3, 4, 5, whatever you need. It says number 1, a positive charge is attracted to a blank charge. So let's go to the simulation. Let's find out. So we have this balloon here. And you can see the balloon has positive and negative charges. Let's take this balloon and rub it on this sweater. Now this sweater has positive and negative charges as well, because everything around us is made of atoms. So this sweater is made of atoms, the balloon is made of atoms, this wall right here is made of atoms. And these atoms have positive and negative charges. All right, so let's see what happens if we put the positive and negative charges close to one another, as in the atoms of the balloon to the atoms of the sweater. Look at this. The balloon is pulling those electrons, those negative charges. Remember, the electrons have negative charges. So this balloon is really negative now. This balloon is loaded with negative charge. Now, if I let it go, it goes straight to what charge? The negative charged balloon now is drawn to what charge on the sweater? You can see the sweater has positive charges. So if the negative is drawn to the positive, that must mean that the positive is drawn to the negative. Vice versa. So if negative is drawn to positive, positive must also be drawn to negative. So in your notebook, let's write number 1's answer. It says a positive charge is attracted to a negative charge. Positive and negative are drawn to one another. They have an attraction. Let's answer number 2. It says a negative charge is attracted to, that's right, a positive charge. So number 2 is done. All right, let's look at number 3. Number 3 says, explain your evidence of similar charges, plus or negatives, repelling each other. So we need to find out, do positive and positive push each other away? Do negative and negative push each other away? Do they repel? Let's find out. So we'll find out the answer to question 3 by going over to this wall. Look at this. This balloon is negative. When I bring the negative closer to the negative on the wall, do they push each other away? Or are they attracted to one another? Here, they're close. But when I bring all the electrons on this balloon, all the negatively charged electrons on the balloon, they push away the negative here. We can see that the negative charges push each other away. They are not attracted to each other. So positive and negative, attracted. Negative and negative, push each other away. They are not attracted to each other. But look at this. The negative charge here is attracted to the positive charge on the wall. But the negative charged balloon pushes away all the electrons of the atoms that make the wall. So negative pushes negative away. Here's a little help to answer question 3 if you need it. It says the blank charge on the wall repelled the blank charge of the balloon. So go ahead and fill in the blank just based on what we saw when we... There you go. The blank charge on the balloon pushes away the blank charge on the wall. Go ahead and finish this question. Fill in the blank. All right, number 4, it says the positive part of an atom is what? What is the positive part of an atom? We can go back to this picture. This is slide 25, and this helps. You can see the positively charged particles in the nucleus. So the nucleus is positively charged. And if we use the key, you can see which part of the nucleus has the positive charge. All right, then we can go back. It says the negative charge belongs to what part of the atom? So we can come right back here. And the electron definition for slide 25 says negatively charged particle. So the negative particles on the outside of the atom are the electron. All right, for question number 5, all you got to do is draw this model of an atom, but label which is the proton and which is the electron. That's all you got to do for slide 26. Let's keep it moving.